Hello everybody and welcome to another shader graph tutorial. In this one we are going to look at this street water type of thing effect, and it's based on the height map that is given to the shader. So you need a texture and a height map in order to do this effect, and I have some other samples like this one or this one or this one. This one's bad, this one's nice, or maybe this one and this one. And I just want to say thank you so much. Your views and support and comments means a lot to me, and without them I would have never made any of these videos. I do not monetize my videos, and the only way I get support is by buying my assets. Links are in the description. So thank you so much, and let's just jump into it. So I have this scene from this RPG FPS game assets, industrial asset from the asset store. It's for free, you can download it. I just re-imported all the materials to be able to run in the lightweight render pipeline, and I already created a shader which have all these properties. You can create them as we go, or you can do what I did, and I just did that because of the bug that I need to create each one and then save and close and reopen it in order to be able to continue on editing. Okay, and I created a material out of this one. You can forget about these, I'll show that later. So it's just a material out of this shader, and I assigned it to these pieces of the street. So what do we need? Let's start by just getting the albedo and entering it to this sampler, right? And what we need is we want to lerp between the original value of the texture and the value multiplied by the watercolor, right? And use that for the albedo. Now this value of t that we are going to lerp on is coming from the height map, right? So I guess I have it as displacement, I'm sorry. So let's just do the same for this one, and let's see. So because the textures that I found are very different, so you probably will need to do this, which is multiply this value by whatever contrast you think it should be. So that's multiplying it by one value, which will produce, let me show you. So value of 1 is the same value of 2. You'll see the light areas are going lighter, right? The values of the positive values goes multiplied basically, and then if there is negative values it will be even smaller than what it was before, right? All right, and then after multiplying, which will do some contrast, right, we want to add to this value and we are going to add our height value, right? And then this will go to a clamp because we don't want any value to be less than 0 or greater than 1. And then we can use that to lerp, right? And we can see this might be the opposite, and it is because, well, you can always use a negative contrast value, which will negate what's the high areas and the low, right? And changing the height to 0, you will see there is no water. Changing it to 1, there is more, and to 2, everything now is water, right? So you can actually save that and see we have this thing here, and if you change the height, okay, pretty cool stuff. Now you can add, oops, let's move this backwards, and you can add to this value some random value, right? Which is going to be a noise, a gradient noise, and we are just going to add this value to this one and use it instead. I think I did not create values for this one, so let's create some of them. We want noise height, and we are just going to add this value to the noise, and we want noise scale, and let's just connect the noise here. Let's default it to 10, and we want to UV map this noise based on the position in world coordinates. So based on the X and Z of the position, which I will show you in a bit how it looks like. And we can save that and take a look now. So let's decrease the height, and let's make the noise scale maybe 1. And now you can start to see if we give more height, whoops, if we give more height, you get the idea. You can see now it's only these parts. Now this is a problematic because this value is going to be maybe less than 0, and so you will start doing these negative values, and which will affect on your original height and stuff like that. So we can just connect this to a clamp before using it, and we should be in a good shape. Now we can also use the same value, this one, to lerp between you guessed it, the smoothness, so that the water have a smoothness of whatever we want, which is just a value like this, and the normal. You can also add a property for the non-water smoothness, but I'm just going to keep it as 0. Let's create another one also for the metallic value of the water. And let's keep that 0 and use the same value. And let's save that and look at that. And now you can see that the water areas are, well, reflective, right? Let me give more contrast. And let's go with 1, let's reduce the height. And we can see that it's not, the randomness is not affecting our values, and that's because of how contrasted our values are. So all what we need to do is to add another property, noise contrast or noise multiplier. And then all what we need to do is to multiply this by our contrast value and use that instead. Let's default it to 1. Let's save that, check that out. And obviously this does not do anything because of our clamp. So let's actually just remove the clamp and connect directly. Save that. Go with some contrast on this and reduce the height. Now you can see, and let's maybe make the scale smaller. Now you can start to see this nice areas. Right. So using the world coordinates or the world position to map the UV will make places like this where you have different pieces just blend in together, right? Alright, so let's add some tiling to our texture. And let's use this vector 4 tiling and offset, split it, and create vector 2 and another one. Connect this to tiling. Connect this to offset, and let's use that instead. And you obviously need this to be connected also to this dude, the height map, right? Now we can also create or use our normal normal map connect it to, again, the same stuff, and use normal, and we are going to blurb again between the value of the normal and just 0 on everything except for the Z, because that's the basically the normal of up, and again use the same value and connect that to the normal. We can also go through a normal strength, and let's use this normal strength property instead. Let's save that, and now we have some normal mapping, and that's already used here, right? That looks actually dope. You can change these to have more details, maybe something like this. So to add a bit of a refraction to your water, which is this place here, what you need to do is to create a different sampler, and let's use my method of refraction. So it's going to be view direction node refracted by the normal, normal vector with some index of refraction, and it's going to be a custom node, and we will have our inputs, 3 inputs, the view, the normal, and the index of refraction, and we will have 1 output, which is, come on, which is vector 3 as well, and it's going to be a string, doesn't matter the name, and we are just going to say out is equals to refract, and that's a function provided by HLSL, and we will put in the view, so that's the vector that we want to refract, and we are going to refract it using the normal of the object and for the given index of refraction. And don't forget to normalize the view and the normal map. And this is not actually going to connect directly, but rather it will go through or it will be added to the tiling, I'm sorry, to the offset, and then we will use that to unwrap. Alright, now if we have a value of 0.2, you will start seeing this weird stuff, and then we can also multiply this by, you guessed it, the same value, and this is starting to look a bit complicated, even though it's not that complicated. and you can probably arrange these in a better manner, but I'm just not gonna do that. So I'm using the same value of whatever height calculation we are using, so that we don't have we have less refraction while transitioning between the water and the non-water. You cannot really see it right now, but we'll see that in a moment. Let's save that. Let's go back here. Now the index of refraction here has to be very, very small. That might be a little bit too small, so let's 2.2 maybe. I think that's fine. Now, what I want to add also is some random normalization. Now, what I want to also add is some random normal mapping, and what I mean by that is a noise which will connect to normal from height. And this is just gonna create a normal map out of this height, and then we can create tiling and offset, use that, and use some time, and you can multiply by the speed that you want, or let's actually do that. Multiply by, let's go for 0.2, go to the offset, and what you can do is you can blend these with this normal map. That's a little bit too much probably, but let's take a look. Yeah. Let's do some normal strength. Let's use 0.2 out of that. Let's save and take a look. Looks a little bit better. And actually we can use the same noise to add to our height. And that's obviously too much. You need some multiplication for that. Maybe 0.2 or something. And you can parameterize that also. probably want it to be even slower than that. Point maybe 1 or even 0.5, and a little bit more. Now you start to see all the blending and the movement of the height. Maybe that's still a lot of refraction. But I think this looks good enough. So I'm just going to show you some samples that I made previously. That's almost the same one. This is just using some different textures, and again this is like one layer of faces, right? It's flat, but it makes the illusion of it being not flat. Now sometimes you find some textures that are not great, like these ones, so you should pick carefully, or maybe like this one also. So that's gonna be it for this tutorial. Consider to hit that subscribe button. Thank you so much for watching, and have a nice one.